All right, here we go with the final set of types for these uniform acceleration questions. There might actually be different combinations of information possible. I haven't checked that, but I mean, after we've gone this far, it tends to be just kind of straightforward. They start to seem all the same. People tend to comment. And so types 7 and 8. So we're going to give you initial velocity, displacement, and time, and ask for final velocity acceleration. And type 8, kind of the trickiest of them all. Give you the initial velocity, the displacement, and the acceleration. And we'll ask for the final velocity and the time, and you'll see how they work and why number 8s are the hardest one. Okay. So here we go. I skipped giving the story for this one, just cut right to the chase. This is the given information you pull out of a story. If you're told that it's speeding up, you'll be able to draw a VT graph starting at 10, going to a final velocity that's unknown, a known amount of time, a known displacement or area, right? So that should be normal here. And then if you're looking at, pretend I didn't show that yet. If you're looking at whether you're starting with acceleration or displacement, basically slope or area stuff. Since you have displacement, of course, you would start with that one, right? So you start with displacement stuff. You can do the normal work of adding up the areas, and the numbers can go in, and you can solve for. Excuse me. All right, so numbers go in, and yeah, just your v2 minus v1 like normal, and so the v2 minus 10 and so on. And you can solve out algebraically to have an answer of 16.67 meters per second. Once you have v2, of course, you can just do acceleration concepts like normal. Okay, so press pause, of course, if you need to slow this all down and whatnot, but that should be very doable at this point. Okay, not no major surprises on this one. Notice that this couldn't possibly be a slowing down case because if you're slowing down from 10 in 6 seconds, you'd only be traveling 60, or you'd be traveling less than 60, and you've traveled more than that. So logic-wise, if you if you didn't know, it would actually spit out the right number anyways, like I've shown you in the past. But again, of course, questions are usually clear enough that you know what's going on, and you just analyze based on that. With the equation version of things, we can do either one we want first. And so we could even go ahead and do, one's getting acceleration first. So we got acceleration last than the last time, right? Yeah. So here we can go ahead and get acceleration. So if you look at finding acceleration circled, times are circled, v1s are circled, and displacements are circled, you can see we can use this equation. Okay. So there's the equation, plug the numbers in, just algebra work to solve for the number, and we get that same acceleration value, the 1.1, just like we had before. There's a couple more, another decimal place kept before, but same thing. Okay. And then if you want to get v2, well, then you're going to, I guess, erase to make it easier here to look at what we're working with. Erase the acceleration ones, put on v2, circle the v2s instead, and then you can see that we're going to work with this one at that point. So that would give us the v2 equation, the equation for v2, I should say, right? Plug in the 80 and the v1 and the time and so on, and just solve for v2. Okay, so that's going to spit out the same number as we got from the graphing method. Okay, so nothing really too surprising there. I hope you agree. The slowing down case always has that little trick to it, right? So watch for that. In the slowing down case, pretty much just showing this, but this case here of a slowing down version. So if we're slowing down from 40 and we're traveling this displacement and so on, we could go ahead and put values in here, but this delta V represents a negative number, and so you'd have to put in negative of it. So you'd have to actually put in 40 minus V2. Okay. I'm just going to show this quick, and this question was made by actually calculating out how long. Like basically, I chose 5 seconds and 40 and a final of 10, and calculated out what the displacement would be. So what we're doing right now is we're working backwards to get the numbers that I chose. Just trying to sort of let you peek behind the curtain here to see that everything makes sense, right? I can pick numbers, calculate a displacement, and then know that we're going to be able to calculate those numbers I picked, right? The final velocity and the acceleration and so on. So our displacement concept, the areas and so on, this is the one where the delta V is a negative number. And so we have to be careful and put it in as the positive version of it, right? So negative of that thing. So we're putting in 40 minus V2. That's our actual positive height of the triangle, which is technically negative of the delta V. And we run the numbers and we get an answer here of 10 meters per second. We're getting that 10 that I chose in the first place, right? So hopefully that's making sense to you. I'm showing that it works. I can also, of course, do this with equations and see that we get that same number. And it's with the equations, you don't have this complication of this hidden negative height of a triangle accident. Oops, that's not what I want to do. There's a modified approach for this one that is neat to look at too as part of this learning process. And so if we think of the whole rectangle, take away the triangle, that actually develops into that v2 delta t minus 1/2 acceleration delta t squared equation, right? So you can see the logic of that equation and why it's useful. Okay, so that gives you delta v. What was I doing with this one? And then we get work towards getting the v2 equals 10, I guess, in a slightly different way there. But so this same equation now, right? Same stuff, same question, I should say. Exact same question, just done with equations. And so if we're looking at getting the acceleration first, it's the green and the stars. So green and stars would be this one. Okay, so that's that equation right there. So let's just make sure green with stars, that's that equation there. So we plug numbers in, solve out, and you'll get the -6 that you'd get wherever it was. I don't know if I ever did that one or not. Did I? Yeah, I did it then. I just didn't talk about it. So once you have that 10, of course, it's just a delta V, with delta acceleration was delta V over delta T. So the -6 confirmed nicely here with the equation work. And then for V2, the red version with stars. So red and, it's not as easy, but red and 2 stars, or and 3 stars. So it'll be this one. Prefer just having a single UASIM sort of circled and set up for selecting, right? But that equation right there, plug numbers in, solve it all out, and you get your final velocity. Okay, so obviously the advantage of the equations for this case, right? You can see the advantage of the equations for this case, and if you can remember those equations, my point here is, you can see the advantages of the equations, particularly for this case. Sometimes it's kind of like either way is fine, right? But being able to get these numbers without the complication of the negative hidden height is, of course, an advantage. Type 8, right? So here we go with type 8, and this is where advantage of the equations also kick in, more so. So we have a V1 displacement and an acceleration. So initial velocity, displacement, and acceleration is given. We're asking for the final velocity and the time. And so as a graph, you could set this up. Initial velocity, we're accelerating. Those are in both positives, so we're speeding up. There could be obviously a story to deal with this as well, but pick out the key information and you have it. With this one here, you're looking at saying, okay, well, do I start with, as we usually think of, right? Do we start with acceleration or displacement? If you look in acceleration, in the acceleration equation, we have the acceleration. We don't have the delta V and we don't have the delta T. In the display, that's not good news, right? You got 2 unknowns there. In the displacement equation, you have that one and you have V1, but you don't have delta T and you also don't have delta V. So in both of these equations, you can't use them just on their own because there's 2 unknowns in both of them. So that often stops people in their tracks and makes it so you can't continue. Well, in actual fact, you can. You just have to have more math knowledge to be able to make it happen, right? So hopefully maybe some of you are looking at that going, wait a minute, we've got 2 equations with 2 unknowns. We've seen this before, right? You can do substitution and elimination, which in this case then leads to a quadratic that you have to solve. So quadratic substitution elimination for linear system stuff. And then on top of that, a quadratic afterwards to solve. So pretty much the 2 parts of grade 10 math that give people the most trouble. So as a grade 11 physics teacher, I say, hey, let's use equations, right? Let's just get the physics answer and use the equations. they have all of the results, the knowledge, the necessary knowledge of this stuff built into them. That's why they're powerful, right? So I will show this, just, follow along and just see that it's true and makes sense, right? So this question, if we were to plug the stuff into the displacement equation, we have this, right? So we could solve that one out to look. Oh, sorry, actually, no, this is the one equation. The other equation, so I should do this. This right here would be like equation 1. And right here would be essentially equation 2. And then when we solve for one of the variables and plug it in, what we're doing here into there is substitution. Okay, so I always just use SUB'(n) for substitution as a short form. So that is the combined equation that ends up being one variable only, just delta t, but it ends up being a quadratic. So you have to use the quadratic formula to solve, and eventually you get an answer of 4.34. Okay, if you follow all the numbers, it works. And then once you have that, you can get the final velocity. So it's not that it's not doable. It's just maybe more math than we want to chew on in a physics class, right? And so here we go with equations. Okay, exact same question. We're hoping to see answers of 4.34 and 36, right? And so if we wanted to solve for V2 first, right? There's your stuff. You can choose the equation. So the equation we choose would be this one. We plug numbers in. And by the way, I'm going to show you, like, it's easier to solve for V2 first. I'll show you why. But well, if we solve for V2, right, we get, all just works out algebraic, and you get that 36 number. And technically when you're solving here, you get plus or minus 36. And of course, the logic of the question is we're speeding up. So it's going to be the positive number, right? The negative number is just not a valid answer for the physics in the question, okay? So solving for V first is nice because you can just go ahead and solve, right? If you tried to solve for delta, if this is continued on, now that we have the 36, we can just do a regular acceleration work and get our 4.35, okay? So that's the way I'm recommending. Solve for V2 first, and then use the V2 to get the time. If we didn't use the V2, or in other words, we didn't solve for V2 first, we tried to just get time first, then we end up with this equation being the one we pick, and we have a variable of delta t, but also a delta t squared. So we end up with a quadratic that we have to solve. So again, why not make the healthy choice, the easy choice of solving for V2 first? That way you avoid having to do the quadratic formula in the context of a physics class, okay? So yeah, that's what I'm recommending. Slowing down case is going to be the same kind of thing, right? So it doesn't really matter with equations. So I'm just going to leave it at that. And yeah, so there are extra questions down here that I've been pulling from. So some of those you've already seen. Up here, I've got a question here. I gave 3 of the type 7 because this one starts from rest. And so it's ones that start from rest tend to be a little bit easier. And I don't want you to just think they're always that way. And so I've got a speeding up and a slowing down version of type 7 and a speeding up and slowing down version of type 8. Okay. And really just go for it, and use the VT graph if you want for these as well, for some of them, but with the type 8 ones, you're just going to use the equations. I'm not going to force you to, right? So I would say with speeding up, you could use VT graph just to make sure you keep that skill handy. And then you could compare with the equation version, but with the slowing down version, I wouldn't bother with the VT graphs. Okay, so because it's the slowing down, I'd recommend equations for this one. Right, use the equations. For the speeding up version, you could use either or. In type 8, 100% equations. Unless you really like doing substitution elimination and quadratic formula solutions, which I don't meet too many people that say that. So there you go. That is it for that type 7 and 8 stuff. And yeah, as always, thanks for watching. Let me know if you need any help. All those things I like to say. And bye for now. There's another one.